the grid is essentially at capacity. You can't plug more generation into the grid without upgrading the infrastructure. And that takes huge amounts of capital. And the national grid is spending billions to upgrade infrastructure. But the pace at which that is happening at the moment just doesn't meet that sort of timeline for the increases in demand. The costs of energy generation and storage, as well as the cost of transmission via the grid, the way those are trending, in 3 to 5 years' time, those two are going to cross, and it's going to be cheap to generate and store energy at the home level rather than transmit that energy via the grid, which is super eye-opening because that's a complete change to how we do energy in the UK and most of the world. We believe that we can get that to 90% or even self-sufficiency at some point in the future. The national grid still exists, but you'll have dramatically less energy flowing through it because each individual building is getting the most of its energy from its own generation capability.
Hey, Scott, thanks so much for joining me today. I really appreciate it.
It's great to be here. Looking forward to being on the podcast.
For those who haven't had a chance to meet you before, tell us a little bit about yourself and the work that you do.
Sure. Yeah. So I'm Scott. I'm one of the co-founders and the CPO at GRYD Energy, a startup in the solar energy space. And we're looking at how we can change the solar model to make solar the default for all new homes so that we remove the cost and the burden of ownership from the homeowner.
Solar is quite an interesting one, and it's one of the sort of key sort of jigsaw piece puzzles in the sort of the wider energy transition that is at the front of a lot of our minds. So I guess before we dive into the nuts and bolts of solar and the work that you're doing at GRYD, we'd be really interested just to get your thoughts on the energy landscape as a whole. So where are we at? We know the energy transition is upon us. But from your perspective, what does the energy transition or the energy landscape look like?
Yeah, of course. So the energy transition sits in the even wider and broader space of net zero. I think that's quite well understood, and people know that essentially we want to get to this net carbon or carbon neutral situation so that we're not pumping out more emissions than can be managed by the planet. And within that, a big part of that is energy and the way we use energy. Up until recently, that has been generating energy in a centralized fashion and then everyone getting their energy supplied by the grid. And that's broadly the same across all geographies, regions, countries, everywhere. And then that energy is generated with fossil fuels predominantly, or at least up until recently. So what we have seen is that homes themselves actually don't really have much control of their energy, and especially their energy spend. It's something that's supplied to them and then they're charged for it. And what that's meant is that we've seen a 30-year trend of increasing energy spend and at the same time erratic price swings up and down in reaction to whatever's going on in the sort of geopolitical landscape and the supply chains. Most recently, everyone will be very familiar in the UK. In 2022, we saw energy bills increase by 81% in a matter of weeks and months, obviously caused by the conflict in Ukraine and Russia and what that did to the global supply chains and the energy markets. So that doesn't really give you much control over energy and your spend on energy. And at the same time, we're seeing, because of the push towards net zero, increase in electricity demand. So we are electrifying our infrastructure, we're electrifying our transport, switching to EVs, we're electrifying our home heating. And what that means is we are going to see a doubling in the energy demand in the UK over the next decade. And the previous doubling took about 50 years. So we're going to need a lot more energy very quickly.
Some of those numbers are pretty shocking. The energy cost increase that everyone in the UK has experienced, the demand for new energy. So we're aware that your national grids, for example, are trying to get more renewable energy plugged into the grid
Mm.
from sources like offshore wind. And there's that sort of that famous 10-year wait with the connections queue. But what sort of pressure does that increase in demand place on energy companies?
There's a huge amount of pressure. So the grid is essentially at capacity, and you can't plug more generation into the grid without upgrading the infrastructure. And that takes huge amounts of capital. And the national grid is spending billions to upgrade infrastructure. But the pace at which that is happening at the moment just doesn't meet that sort of timeline for the increases in demand. And that's why it's important to move from this centralized energy generation scenario that we currently have to a decentralized energy generation, smaller scale, localized energy generation. And that could be community energy, that could be home based generation, just moving it away from these big central hubs of energy generation that there's this massive transmission cost to get it to wherever it needs to be. And then the other element to that is storage. So local or regional storage as well. At the moment, when we generate energy, it pretty much needs to be used at the point it's generated. So if it's a very windy day, there's loads of energy being generated, more than we actually need quite a lot of the time. But we don't really have good means to store that energy at the moment for use later when the wind's not blowing as strong or the sun's not shining as strong. So yeah, that's the situation where we need to get to this point where we've got a decentralized system of generation and storage asset.
Decentralized generation. So is that does that tend to refer solely to smaller energy companies, or is it actually at a consumer level? What does the opportunity look like there?
Yeah, more and more it's moving towards individual consumer level generation and storage. I had an interesting conversation with a guy called Andy, and he is the founder of a company called Solar Zero in New Zealand. And he highlighted that the way the costs of energy generation and storage, as well as the cost of transmission via the grid, the way those are trending in 3 to 5 years' time, those two are going to cross, and it's going to be cheaper to generate and store energy at the home level rather than transmit that energy via the grid, which is super eye-opening because that's a complete change to how we do energy in the UK and most of the world.
So does that save money for at the consumer level? So do you think that would then bring down our energy prices, or is it more, or is the benefit more around sort of general energy supply resilience on a national scale?
Yeah, so it's a little bit of both actually. So on the energy security point, if you're generating and storing most of the energy that you use, you have very high certainty about how much that's going to cost. And that's why you see, especially in the solar space, people can lock in energy costs for 25 years. There's no other asset in the world you can know is going to cost the same amount in 25 years as it does today. So that's one benefit. And because of that, it's not the energy costs aren't linked to any of the sort of geopolitical or market activities. So you can be pretty sure that your energy price is going to stay the same. There's not going to be any erratic swings in price that you may have to try and adapt to at some point in the future. You just know what your energy is going to cost. And that essentially makes that cheaper.
So you mentioned solar. So let's dive into solar. I think I've got to ask just off the bat, the UK, it's a bit of a cliche around our weather, but how suitable are we in the UK for solar, and how actually dependent is solar energy on a shining sun?
Yeah, no, it's a great question. It's one that gets leveled at us quite often. But the reality is that the UK is great for solar, and not just in the south, but there are solar panels on homes, on buildings, on commercial premises the entire way up the country, all the way up to Scotland. And yeah, we do have this reputation of being a pretty grey, rainy climate. But over the course of a year, a typical home in the UK is able to generate, based on a sort of standard home solar installation, they would be able to generate more than enough energy to support them in terms of their overall energy needs. Typical home will need around sort of 3.5 to 4,000 kilowatt hours of energy a year, and the solar system on the roof will generate in excess of that. The challenge is that there is this seasonal variation, so you're generating much more in the summer than you are in the winter, and your home's energy use doesn't necessarily always line up with the energy when it's generated. If you think about when the sun is strongest, there's a peak in the middle of the day and a drop off in the evening. Whereas a home's energy usage will typically peak in the morning when they wake up before work. It'll dip in the middle of the day and then peak again in the evening time when they get home. So while a typical solar system will generate enough energy, or more than enough energy for a home's needs, they won't necessarily be able to use all of that energy for themselves. So that's where battery storage becomes very important, because when you're out, you can store that energy for later. A typical home will be able to, it's called self-consumption. So a typical self-consumption rate for a home with solar will be around 60 to 70%. And that means they're basically getting 70% of their energy from the solar that they generate. Anything they don't use, they can export back to the grid and actually be paid for that. And then that remaining 30% that they're not getting from solar, they would have to source from the grid. But yeah, there's many ways you can increase your self-consumption rate. And one of the things we are doing at GRYD is looking at how we optimize the home's energy demands so that they're maximizing the amount of energy they get from the solar versus the traditional grid.
I was just thinking about solar in the UK, and it's interesting to see the rise of solar around the world. And there's in Australia, in the US, it's been steadily increasing over time in many ways. But in the UK, I feel like we were ahead of the curve quite a few years ago, and then it's dipped. And now actually, over the last few years, you haven't seen that much solar really pop up. Do you see that same trend? And are there any sort of reasons for it?
Yeah, that's a good question. So the UK actually went quite early out the gates with solar back in the early 2010s. And there was a government scheme, the feed-in tariff scheme, which essentially gave a payment to people who adopted solar on their homes for all of the energy that they then exported to the grid. Those payments were very favorable for the people that had solar. It was quite a high expense to put solar on your roof at that point in time, but they were getting up to pence per kilowatt hour, which is even higher than we pay today for our energy from the grid. So what you saw was a lot of people put solar on their homes, they used what they needed, and everything else got exported to the grid. But with those kind of payments being made, it wasn't necessarily a sustainable model. It got a lot of solar onto the homes, but as soon as those subsidies dried up, that just couldn't be sustained. And then we saw a big drop off in the amount of solar that was deployed. There's been since that, it was quite a sharp drop as well. So the feed-in tariff scheme ended in around 2013, and you immediately saw just a drop off in the amount of solar being deployed. And that's partly because of the economics of solar at that point in time. So a typical system may have cost 10 to 15, maybe £20,000 to install. And the panels themselves were less efficient at generating energy. But over time, since then, the technology's moved on in such a way that the efficiency has increased by about 50%. The manufacturing costs have come way down. by around 80%. Um, and the economic case for solar has just got better and better over time, and quite drastically better. Back then, your cost per watt of generation was probably around £2.50. And today that sits probably in the region of sort of 25 pence per watt.
Wow.
So
Wow, that's a massive.
just
Yeah.
dramatically more economic to use solar. And also the efficiency means that to get enough energy to support your home, you would have needed to deploy, say, 16 to 20 panels. And today you need to deploy 12 panels. So the actual amount, the area or roof space that you need has dramatically come down as well. And those trends are continuing and are expected to, the price per watt is expected to go down another 50% or so over the next decade.
It sounds as though the equation for solar has dramatically improved over the years. Are we seeing the amount of demand for solar pick up following the slump after the scrapping of the feed-in tariff?
Yeah, so over the past sort of 2 or 3 years, especially, and especially with the massive price hikes we've seen in people's energy bills, people are desperate for savings on their energy bills, any kind of way that they can. So actually, 2023, we saw the highest amount of solar deployment in the UK for 12 years. And that basically takes us back to when the feed-in tariff ended, because people are just searching for ways to reduce their energy bills. And that equates to about 200,000 systems deployed last year alone.
It sounds though consumer demand is actually responding quite well to the fall in costs and the improved efficiency in the solar systems. What other challenges currently stand in the way of just wide scale adoption? We know climate change is happening, but the weather isn't going to change that significantly. So it then leaves the cost to go down further, or what, incentives and subsidies to go up. What sort of challenges or hurdles are still in our way for wide scale adoption?
Yeah, so this is the fundamental reason why we founded GRYD. Yes, solar adoption is going up, and rightly so, the economics are much better. But as we talked about earlier, at the same time, energy demand is going up. For example, if you add a heat pump to a home, which is a very good thing to do, that pretty much doubles the electricity requirement for a home. So we said earlier, 3,500 kilowatt hours. A heat pump will add about 3,500 kilowatt hours of electricity demand to a home. So what that means in terms of solar is you'd need a bigger solar system to actually get all the electricity you need for that home. And what we are also seeing is that even though the cost per watt is coming down, the cost of deploying a solar system is staying pretty flat and is actually increasing slightly. So typical cost of deploying a solar system, if you include a battery as well, £10,000 to £12,000, £14,000 on maybe a larger home. And that's still quite a big investment for a home to make.
So tell me about the work that you're doing at GRYD.
What we uncovered when we were speaking with customers was that it's actually the ownership model of solar that has been done to date that is blocking people from adopting solar. Because one, there's the cost element. You have to purchase and own that system. But two, people living in homes in the UK are not always sure how long they're going to be in that home. And solar has a payback period of about 8 years at the moment. And a typical new homeowner will expect to move within 5 years. And actually, first-time buyers especially, 60% of them do move within 5 years. So with an 8-year payback period, there's no economic case for them to purchase and own a solar system on their home. And then regardless of what it can do for their energy bills, they just won't make it back in the duration they expect to be in their home. Yeah, that's essentially where GRYD comes in. So what we do is we fund the solar systems on homes. We then own, operate, and optimize them on the home's behalf. And we generate and supply that energy directly to the home behind the meter, cheaper than a traditional retailer can. So the home gets some of the benefits of having solar, no upfront cost, and zero payback period to worry about. Um, and we're actually working with new build developers in particular to make solar the default for all new homes. And developers themselves have their own challenge in their new building regulations that came out in 2022, but really started to take effect last year, that mandate a carbon emission reduction on all new homes of 31%. And to meet those regulations, developers are looking to solar, one, because it's reasonably cost effective for them, and two, because solar is actually pretty well understood and well liked by the public, and is actually the most popular form of power generation by the UK public. But as you can imagine, that's meeting those regulations still comes at a cost to the developer, and that's a cost they want to minimize. So what we've seen is that a developer will put a number of panels on a home to meet the regulation, which can be 3 to 4 panels, which doesn't do a huge amount for the home, but it gets them past that building regulation bar. With GRYD, what they can do is, because it's funded by us, essentially, we can deploy a full scale system on that home with battery storage and all of the intelligent comms, so that roof can be fully utilized to its maximum potential for solar generation, and the home can get a meaningful amount of their energy from a renewable source.
So it's a really interesting approach that you're taking, and going the developer route. As you said, it removes the pressure or at a consumer level to make solar a widespread renewable energy source. I'm all for new solutions that remove the onus from at a consumer level, because the ability for developers, for asset owners and energy companies, etc., to actually really leverage their scale and their reach to be able to introduce these new solutions that the planet needs. I think it provides such a better route to market for these new capabilities. So from the sounds of it, does that remove the need for like a traditional energy source, or does this solar with supported by the battery sort of sit alongside your sort of traditional grid connection?
Yeah, no, that's a great question. At this point in time, a home will still have a traditional grid connection. And if we go back to what we were talking about earlier about the grid capacity and the transmission from centralized resources to a home, if you're deploying solar and storage on a home, you're sitting behind the meter. So none of that energy, if it's used by the home, is adding to the capacity issues in the grid. So if you shift a home's energy, the majority coming from the grid to the majority existing behind the meter, the only energy that's flowing through the grid is the excess that home can't use. So we talked about it earlier, that 30%, which GRYD is trying to minimize. We believe that we can get that to 90% or even self-sufficiency at some point in the future. The national grid still exists. It's still a thing, but you'll have dramatically less energy flowing through it because each individual building is getting the most of its energy from its own generation capability.
So the economic model for developers, you touched on it before, but would love to understand that in a little bit more detail. Why would a developer introduce this?
There's a few things at play here. The regulatory changes are great in that we are minimizing or reducing a home's carbon emissions. And there's actually a new set of regulations coming in 2025, next year, called the Future Home Standard. So that 31% reduction in carbon emissions is actually going to be a 75% reduction in carbon emissions. So these things are increasing all the time. And we also mentioned that puts a cost on the developer to meet those regulations. But you would think that cost can just be passed on to the homeowner in the house price. But the other thing that's going on is obviously we have a bit of a housing crisis in the UK. We have a shortage of new homes being built, and the homes that are built are increasing in price and becoming more and more unaffordable to a wider and wider portion of the population. Even so, my sister is going through the process of trying to buy a house right now. And for many years up until now, get to a point where she thinks she's got enough savings. She then attempt to look at some properties and then realize that she's about 6 to 12 months late because the house prices have increased and she's now getting pushed up and up. So that puts a strain on the developer to try and make their houses affordable. And at the same time, we also see homeowners not necessarily value solar in a way where they'd be willing to pay a premium on a new home that had solar installed. Yeah, a few market forces at play, but it's not quite as simple as just putting the solar on a home and then someone will buy it. A direct quote from a developer that we'd spoken to is that they'd love to put full scale solar on all new homes, but the thing that sells the home is the granite worktops in the kitchen. So it depends what you place the value on. But yeah, solar is not necessarily up there as something that people are willing to pay more for on a new home.
Energy prices, I'm sure, will forever increase. But to tackle that, as you've described, which is such an interesting concept, you remove it. You say, okay,
Yeah.
you don't want to pay for it. You don't care enough about solar to pay a premium. Fine, remove that completely. So there's really the barriers for actual wide scale solar adoption are completely removed, which is it's such an incredible model. Scott, thank you so much for your time. I really appreciate it. It's been absolutely fascinating. Thank you for joining us.
Thanks, Jack. Yeah, it's been great to talk to you.
Thank you.